Let's consider a heating curve of water. That is what's going on with the temperature as we add heat at a consistent rate. We're consistently adding heat and we're monitoring the temperature. In this example, we're starting out at minus 10 degrees C. The water is going to be in the solid phase. As we add temperature, the ice, solid water, is going to increase in temperature, and then it reaches a plateau region. At this point, the heat that is added to the sample is no longer going into changing the temperature, it's changing the phase. It's melting the ice to liquid water. And during that process, until all of the solid water has been converted to liquid water, there's no change in temperature. At this point here, the last of the solid water has melted, and now the heat that's added to the system is going into increasing the temperature again. And the temperature continues to increase until it reaches 100 degrees, where another phase change occurs, the liquid to gas phase change. At this point, the heat that's being added to the system is being used to vaporize the water to gas. Then once all the liquid water is vaporized, then the gas is increasing in temperature. And if we look at quantifying the heat in each of these different regions of the heating curve. Initially here, this is a temperature change region, and the heat is going to be calculated by the mass times the specific heat times delta T. Now, as we've learned in our earlier problems, the value of the specific heat of water depends on the phase. And if you look at your equation sheet, you'll see there's different values for the specific heat of water depending upon whether it's in the liquid, solid, or gaseous phase. The phase change regions, the heat is going to be quantified by the mass times the heat of fusion if we're dealing with a melting or solid to liquid. And if we wanted to quantify the heat involved in the phase change going from a liquid to a gas, we would use the heat of vaporization.
Summary of important information for these heat problems. Enthalpy of vaporization and fusion are values that are used when you're doing a phase change. We have different values for the heat capacity of water given depending upon the state. And for all of these values, there's equivalent values given in calories versus joules. So you just want to take note of what your question is asking for. This question asks for calories of heat, and we're melting some amount of solid water or ice, and we're already at the transition temperature. We note that this is a phase change. It's a phase change of solid to liquid, so the equation we use is heat is going to be equal to the mass times the delta H fusion. Further, the question specifies calories, so we look up the value for delta H fusion given in calories. We see it's calories per gram. Our amount is given in kilograms, so we're going to have to do that conversion. And we substitute in our values. In our conversion factor, we note that kilograms is equivalent to 1,000 grams. Kilograms is in the denominator so that we can cancel. And similarly, grams now cancel with grams in our delta H fusion, leaving us with units of calories.